Good morning, students. Am I audible? Hello, please write in the chat box. Am I audible? Today we will start a new topic that is called triple product of vectors. Suppose let A bar, B bar, and C bar be three vectors. Suppose there is a cross product between A and B and the dot product with C. So A cross B will be a vector, C is a vector, then dot product of two vectors is a scalar. This is called scalar triple product. Then take another case. Suppose this is vector A, vector B, vector C. If you put dot product between A and B and a cross product, so A dot B will be a scalar. So scalar can't be multiplied with a vector by cross product. So this expression will be meaningless expression. In third case, cross product between A and B and cross product with C, A cross B a vector. When it is multiplied with the vector C by cross product, then it will be a vector quantity. This is called vector triple product. So generally triple products are of two types. One is scalar triple product and second one is vector triple product. Scalar triple product, vector triple product. Okay. First write down scalar triple product. Nasrin, scalar triple product. Write down scalar triple product of the vectors. A bar, B bar, and C bar is denoted by box A bar, B bar, and C bar. This is also known as box product, which is defined by box product ABC equals A dot B cross C. Box product ABC is defined by A dot B cross C. So A dot B cross C equals, dot product of two vectors. A dot B is equal to AB cos theta. So B cross C a vector. If you consider B cross C as D, then it will be A dot D. A dot D is equal to A mod D mod cos theta, where theta is the angle between the vectors. So A dot B cross C is defined as A mod into B cross C mod into cos theta, where theta is the angle between A vector A and B cross C, where theta is the angle between vector A and B cross C. Okay, this is called scalar triple product. If three vectors A bar, B bar, and C bar are given in component form, then how to calculate the scalar triple product? Write down scalar triple product in terms of components. Scalar triple product in terms of components. That means the components of three vectors are given. We have to find out the scalar triple product. Let vector A is equal to A1 I cap plus A2 J cap plus A3 K cap, and vector B is equal to B1 I cap plus B2 J cap plus B3 K cap, and vector C is equal to C1 I cap plus C2 J cap plus C3 K cap. Vector A is equal to A1 I cap plus A2 J cap plus A3 K cap. Vector B is equal to B1 I cap plus B2 J cap plus B3 K cap. And vector C is equal to C1 I cap plus C2 J cap plus C3 K cap. Then the box product ABC equals the determinant A1, A2, A3 B1, B2, B3 and C1, C2, C3. Box product ABC is the determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. Come to the proof. Box product ABC equals A dot B cross C. Okay. The vector B cross C is equal to IJK B1, B2, B3, C1, C2, C3. So if we expand this determinant according to along the first row, it will be B2, C3 minus B3, C2 into I cap minus B1, C3 minus B3, C1 into J cap plus B1, C2 minus B2, C1 into K cap. Okay. So A dot B cross C, A dot B cross C will be, so A1 into B2, C3 minus B3, C2 minus A2 into B1, C3 minus B3, C1 plus A3 into B1, C2 minus B2, C1, which is nothing, that is the determinant A1, A2, A3, B1, B2, B3 and C1, C2, C3. Okay, this expression is the determinant A1, A2, A3, B1, B2, B3 and C1, C2, C3. Clear? And this is a scalar quantity. Is it clear, Nasrin? Nasrin, is it clear? Okay. Nasrin को previous class join करनथिलो, exam चलथिला कि? Then come to geometrical interpretation of scalar triple product. वो तबीयत ठीक नहीं था. ओके बेटा. Then come to geometrical interpretation of so before going to the geometrical interpretation, we should solve a couple of rudimentary questions. So write down a question. If vector A is equal to 2I cap minus j cap plus 3k cap, vector B is equal to I cap plus 2j cap minus k cap, and vector C is equal to 3I cap minus 2j cap plus 2k cap. Okay. Three vectors are given in component form. Now question is calculate box product ABC. Okay, next then calculate box product ABC and send me the answer. Three vectors are given in component form. Vector A is 2i cap minus j cap plus 3k cap. Vector B is I cap plus 2j cap minus k cap. And vector C is 3i cap minus 2j cap plus 2k cap. Calculate the scalar triple product, that is the box product ABC. Come to the solution. Box product ABC equals 2 minus 1 3 1 2 minus 1 3 minus 2 2. Now expand this determinant according to the first row or along the first row. That will give it 2 times. Minor of 2 is 4 minus 2 minus of minus 1, that is 1 into its minor, that is 2 plus 3 plus 3 into its minor minus 2 minus 6. Okay, this is equal to 4 minus is 2 is 2, 2 to the 4 plus 5, that is 9, 6 plus 2 8 minus 8 into 3 minus 24. This is equal to minus 15. Okay. Quickly note it down. Then come to geometrical interpretation of scalar triple product. Geometrical interpretation of scalar triple product. Box product ABC represents the volume of the parallel point box product ABC represents the volume of the parallel point whose coterminous edges are A bar, B bar, and C bar. Box product ABC represents the volume of the parallel point whose coterminous edges are A bar, B bar, and C bar. Okay. This is vertex O. This is A. This is B. And this is C. This is called parallel point. O is vector A. OB is vector B. And OC is vector C. Clear? So box product ABC is the volume of this parallel point. So I'll just separate page. ସବୁ ଏଇଟା ଗୋଟେ ଛୋଟ କରିଥାନ୍ତାନି ନା ରାଇଟିଂ ସ୍ପେସ୍ ବହୁତ କମି ଯାଉଛି। ସେମାନେ ଛୋଟ ବୋର୍ଡ କରୁଛନ୍ତି। ନାଇଁ ନାଇଁ ବୋର୍ଡ ଠିକ ଅଛି ଯୋଉ ରାଇଟ୍ ହ୍ୟାଣ୍ଡ ସାଇଡରେ ଦେଖଉଛି ପାର୍ଟିସିପାଣ୍ଟଙ୍କ ନାଁ ସବୁ ଏଟା ପାର୍ଟିସିପାଣ୍ଟ ତ ଭଲ ଅଛନ୍ତି। ଓକେ जो A B C let it be D, this is E, this is F, this is Z. Okay, so this is the vector which is perpendicular to the plane, unit vector perpendicular to the plane containing, this is vector N, B cross C, B and C. So box product ABC, box product are known as scalar triple product or STP. STP doesn't mean standard temperature and pressure, it is scalar triple product. Box product ABC is equal to A dot B cross C. This is equal to A mod into B cross C mod into cos theta, where theta is the angle between A and B cross C. This is equal to A mod cos theta into B cross C mod. Okay, this angle is theta. Now drop a perpendicular from point A upon N, but let L be the foot of the perpendicular in the triangle OAL. In the triangle OAL, cos theta equals to, in the triangle OAL, cos theta equals OL by OA, OL upon OA. OA is the magnitude of vector A, OL upon magnitude of vector A. This implies OL is equal to magnitude of A into cos theta. And you know, cross product represents the area of the parallelogram. So this is vector B, this is vector C, this is vector B, and this is OA is vector A, and OC is vector C. So B cross C is the area of the parallelogram OBDC. B cross C mode is the area of the parallelogram. Area of the parallelogram OBDC. Thus, box product ABC is equal to area of parallelogram OBDC into A mod cos theta is OL. So area of the base, this is base, into height. OL is height. Area of the base into height is equal to volume, of the parallel puppet. Volume of the parallel puppet. Okay, this is the geometrical interpretation of scalar triple product. I hope it is clear. Nasrin, is it clear? Nasrin? Okay. Then come to properties of scalar triple product. Property 1. If A bar, B bar and C bar are cyclically permuted, then the value of the scalar triple product remains unchanged. If A bar, B bar, C bar are cyclically permuted, then the value of the scalar triple product remains unchanged. This is suppose vector A, vector B, and vector C taken in a cyclic order clockwise. Okay. So property says that the box product ABC is equal to box product BCA equals box product CAB. Box product ABC is equal to box product BCA is equal to box product CAB. That is A dot B cross C is equal to B dot C cross A equals to C dot A cross B. A dot B cross C equals B dot C cross A equals to C dot A cross B. So for the sake of completion, come to the proof. Okay. Suppose three vectors A bar, B bar, and C bar are given in component form. So box product ABC will be the determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. Similarly, the box product BCA will be box product BCA is equal to B1, B2, B3, C1, C2, C3, A1, A2, A3. Right? These two determinants are equal. This determinant and this determinant, these two determinants are equal because there is a property in the determinant. If any two rows or columns of a determinant interchange their positions, if any two rows or columns of a determinant interchange their positions, then the value of the determinant remains unchanged. So if you change even number of times, if you interchange the rows or columns even number of times, sorry, if you into rows or columns of a determinant interchange their positions, their value changes by negative sign. So if you change odd number of times, then there will be negative sign. If you change even number of times, then there will be positive sign. So from this determinant to this determinant, we'll first of all we have to interchange the positions of row 1 and row 3. If we interchange the position of row 1 and row 3, there will be negative sign. Again, to get this determinant, you have to change, suppose I'm writing it separately. Suppose we will change row 1 and row 3, a minus sign will develop, C1, C2, C3, B1, B2, B3, then A1, A2, A3, right? Again, interchange between row 1 and row 2. So negative of negative will be positive. Negative of negative will be positive into B1, B2, B3, C1, C2, C3, and A1, A2, A3, right? According to the property of the determinants. So these two determinants are same. So box product ABC is equal to box product BCA. Similarly, we can prove that it is equal to box product CAB. Hope it is clear to you. And then come to next property. Next property is without changing the relative positions, without changing the relative positions of A bar, B bar, and C bar, if positions of dot and cross are interchanged in defined manner, then value of triple product, scalar triple product, value of STP remains unchanged. Value of STP remains unchanged. Box product ABC equals A dot B cross C. Okay. The property says that without changing the relative positions of A bar, B bar, C bar, That means we cannot permit among A bar, B bar, and a C bar. Only we have to interchange the positions of dot and cross. That means dot will be taken into the position of cross and cross will be taken into the position of dot in the defined manner. That means we can write it as A cross B dot C, A cross B dot C, which is equal to, dot product is commutative. This is equal to C dot A cross B. This is nothing your box product CAB. Already in the first property we have proved that box product ABC is equal to box product BCA is equal to box product CAB. Okay. This is nothing only corollary of property 1. Then come to property number 3. Property 3 says that if any two of the three vectors A bar, B bar, and C bar are either parallel or equal, then box product ABC equals to 0. If any two of the three vectors A bar, B bar, and C bar are either parallel or equal, then box product ABC is equal to 0. Come to the proof. Box product ABC equals A dot B cross C. Box product ABC equals A dot B cross C. Suppose B and C are parallel. If B and C are parallel, then angle between B and C will be 0. And B cross C is equal to B mod C mod sin theta into n cap. If theta is equal to 0 degree, then sin theta will be 0. Sin 0 degrees is equal to 0. So if B and C are either parallel or equal, then B cross C will be a null vector. B cross C will be a null vector. So A dot null vector will be 0. Okay. After suppose A and B are parallel, A is parallel to B. Suppose A is parallel to B, then also scalar triple product is 0. B cross C is perpendicular to B as well as C. B cross C is perpendicular to B. Again, it is given that A is parallel to B. So this implies B cross C is perpendicular to A. If angle between two vectors is 90 degree, then that dot product will be 0 because A dot B is equal to AB cos theta. So A dot B cross C, A dot B cross C will be A mod into B cross C mod into cos 90. The value of cos 90 degree is 0. This is equal to 0. Okay. If any two of the three vectors A bar, B bar, and C bar are either parallel or equal, then the value of the scalar triple product is 0. Okay, then come to property number 4. if the vectors A bar, B bar, and C bar are coplanar, if the vectors A bar, B bar, and C bar are coplanar, then box product ABC is equal to 0. Okay. What is the geometrical interpretation of box product? It represents the volume of the parallel part. Okay. Suppose the vectors ABC are coplanar. This is suppose B vector, this is C vector, and this is A vector. If A vector lies in the plane of B and C, then height of the parallel point will be 0. So this is equal to 0. Clear? Then come to property number 5. It KLM basically these properties are properties of determinants. If KLM are constants, then box product of K, LB, and C equal to KLM box product ABC. KLBMC is equal to KLM into box product ABC. Property of a determinant says that if each element of any row or column of a determinant is the product of same constant quantity, then the determinant can be expressed as the product of the same constant quantity. Suppose vector A is equal to so K will be K1 into I cap plus K2 into J cap plus K3 into K cap. Similarly, LB will be LB1 I cap, LB2 J cap, LB3 K cap, and MC is equal to MC1 I cap plus MC2 J cap plus MC3 K cap. Okay. This is equal to, so the K box product K LB MC will be equal to the determinant K1, K2, K3, LB1, LB2, LB3, MC1, MC2, MC3. Right? You see in the first row, each element of the first row is a multiple of constant quantity K. So we can take K as common from the determinant, and each element of row 2 is a multiple of constant quantity L. L can be taken as a common, and each element of row 3 is a multiple of constant quantity M. So M can be taken as common. So taking K, L, M as common, this will be K, L, M times A1, A2, A3, B1, B2, B3, C1, C2, C3. So A1, A2, A3, B1, B2, B3, C1, C2, C3 is nothing. The scalar triple product of vectors ABC. This is equal to K, L, M, box product A bar, B bar, and C bar. Hope it is clear to you. Okay. So write down a question. If A bar, B bar, C bar P3 vectors, then prove that box product of A plus B, B plus C, C plus A equals twice of box product of ABC. Box product of A plus B, B plus C, C plus A is equal to twice of box product of ABC. Come to the proof. A plus B, B plus C, C plus A, box product of ABC is equal to A dot B cross C. This is equal to A plus B dot B plus C cross C plus A. Okay. This is equal to A plus B into by distributive property, we can write B cross C plus B cross A plus C cross C plus C cross A. You know, C cross C is 0. This is 0, 0. Because if two vectors are parallel or equal, then their cross product is 0. Now we have to take the dot product of A This is dot. Dot product of A with B cross C, with B cross A, with C cross A, and dot product of B with B cross C, B cross A, C cross A. You can write this is equal to A dot B cross C plus A dot B cross A plus A dot C cross A. Okay. Then we have to take the dot product of B with others. So plus B dot B cross C plus B dot B cross A plus B dot C cross A. Right? You see, A dot B cross A is 0. If two vectors are parallel or equal, then their triple product is 0. A dot B cross A. Two vectors are equal, that A, so this one will be 0. A dot C cross A will be 0. B dot B cross C is 0. B dot B cross C is 0. What is left over? Left over will be A dot B cross C, that is box product ABC, and the last term, that is B dot C cross A, that is BCA. You know box product ABC is equal to box product BCA. This is equal to box product ABC plus box product ABC is equal to twice of box product ABC. Okay. I hope this is clear to you. So guys, today's session is over. Rest of the things will be discussed in the next session. Nasreen, is it clear to you? Nasreen, only scale a vector triple product is left, and that will be discussed in our next session, and some portions of 3D. Okay. Okay. Nasreen, बंद कर दवा. Sir, not a job. 1 hour session pra? No, sir, latest charge लाती कर तो. अपना मॉल तो भी अपना next class to sir 1 पढ़ाई. इसे 10 मिनट पढ़ाई दिया तो. How? So this question can be solved using a property of scalar triple product. ऐसे उठ के आसिले. आटा के ऊपर ऊपर जो. Okay. Write down another property of scalar triple product. Property next or next property. Box product of XA bar plus YB bar plus ZC bar KA bar LB bar MC bar and PA bar QB bar RC bar equals determinant XYZ KLM PQR into box product A, B, C. Okay. Box product of XA bar plus YB bar plus ZC bar, KA bar plus LB bar, MC bar, PA bar, QB bar, RC bar is equal to XYZ, KLM, PQR, ABC. So using this property, we can solve the previous question. Our previous question was A plus B, B plus C, C plus A. Okay. This is equal to determinant coefficient of A is 1, coefficient of B is 1, and coefficient C is 0. 1, 1, 0. Here coefficient of A is 0, coefficient of B is 1, coefficient of C is 1. 0, 1, 1. Here coefficient of A is 1, coefficient of B is 0, and coefficient C is 1. 1, 0, 1 into box product of A, B, C. Okay. Now we have to expand this determinant along the first row. This is equal to 1 into its minor, that is 1 minus 0, minus 1 into its minor, that is 0 minus 1, plus 0 into its minor, 0 minus 1, into box product A, B, C. This is equal to 1 into 1 is 1, minus 1 into minus 1 is 1, plus 0 into box product A, B, C, which is equal to twice of box product A, B, C, which is equal to twice of box product A, B, C. Clear? Okay, only scalar triple is vector triple product is left. That will be discussed in the next session. And today's next session is physics, which is scheduled at 9 a.m. Okay, stay connected. তাহলে ମୁଁ କାଇଁ ବନ୍ଦ କରିବି? ଭିଡିଓଟା ଖାଲି ବନ୍ଦ କରିଦିଅ। ହଁ।